Welcome back to the course on blockchain and its applications. So, in the last few lectures we have learnt about different possible use cases which can be which can potentially use this blockchain technology for providing an useful solution out of it. And we have also highlighted what are the challenges in the design, and as a designer, as an engineer, or as a blockchain practitioner, so what we should think about and what we should focus on while developing such kind of services. Now, in this particular lecture and the next lecture, that means in our last two lectures of the course, we are actually going to discuss about one of our experience in developing one such use case on top of blockchain. So, I am going to highlight that what was our thought process behind that, and why we have taken up, why we have decided certain primitives behind this design, and how finally we approached to design a solution for that particular problem. So, this is one of the use cases you can think of, and this is something of our experience, the experience from our lab that we gathered while developing this particular application. So, this particular application talks about having an blockchain based solution to design a decentralized electronic marketplace. So, let us look into that in details. The broad concept that we are going to cover, as I mentioned, that the blockchain application for developing a decentralized marketplace, and these are the keywords which we are going to cover in this lecture: the design of a blockchain use case and analyzing the requirement. And in the next lecture, we are going to see that how we are going to achieve a solution for this particular problem. So, this problem comes around the different online service providers which we regularly use in our day to day business. They offers different kind of services to the consumers or the end users, and it typically use a web interface or mobile apps for communication with the customers. Say there are multiple examples of such kind of service providers in different domains, like the e-commerce, the cloud service providers, the media service provider, logistic provider, and so on. So, I can pick up a few examples like this. For example, this Amazon or eBay. So, they are the kind of e-commerce service providers. So, in Amazon and eBay, it is a kind of centralized marketplace where different sellers they can come with their product, and then there are buyers who can choose a particular product from different sellers, find out which seller is providing the minimum cost or the best price, and of providing the best guarantee of the service or the product, and then buy the product from that particular seller. So, this is the kind of e-commerce marketplace or B2C marketplace, what we can say, where different e-commerce site, different sellers come together to sell their product. There are also different B2B marketplace where different service providers can exchange goods and services among themselves. Another such use cases is like in the logistic provider like Make My Trip or Trivago or this Booking.com. That is a kind of consortium of the hotels, the logistic provider like the different kind of flight services, and they actually provide you to compare between different service providers and help the buyers to choose the service, choose the product which provide the best price guarantee. So, that way we are very much habituated of using such kind of services. Now, these online service providers, as I mentioned, that multiple service providers come into an agreement to collaborate with each other. It gain access to the common larger set of end users. So, you have a common platform where every user is coming, and it is a kind of marketplace. So, the users are getting the service from that marketplace. It offer wide range of services under the same platform, like Make My Trip. It provide hotel services, the bus ticket, the airplane ticket, and so on. Similarly, Amazon, it helps in selling different kind of products ranging from electronic accessories the home accessories, the day-to-day goods and so on. So there are multiple examples of such cases as I was mentioning, like different sellers under eBay or Amazon, the cloud infrastructure providers, either on-app federation. So on-app federation is a cloud marketplace where different small cloud service provider, they can come together and they can provide common services to the end user. So it can happen in this way that you can buy the compute resource from one service provider and the storage resource from another service provider in a federated cloud architecture. And then the hotels under Trivago or Booking.com. Where different hotel they come together to have the service for the common people. So that way you have different such type of online service providers. As I mentioned, the e-commerce platform, the trade logistic network. So there are plenty of examples of those. Now, all these existing consortia which we have, those are the kind of centralized in nature. Like either you have a common e-commerce platform where the different seller come together and the consumer buy the product from that, or you have a centralized marketplace where the marketplace is under control of some centralized government agency which actually facilitate the interface through which different service providers can collaborate with each other. So it is mostly a kind of centralized architecture. Now, the limitations of this centralized architectures are as follows, that usually they are governed by a single authority like a service broker or a marketplace. So whenever you have a single authority, you can have this unfair business advantage to the broker. So for example, you will see there are various recent studies which highlight such kind of unfairness and biases in the platforms like Amazon, which possibly knowingly or unknowingly give bias to certain sellers. Then only the service broker or the marketplace provider is responsible for communicating with the end user. The sellers need to share their profit with the central broker. As I mentioned that there can be bias of the broker towards a particular service provider or a particular seller, and there is that way the risk of manipulation and unfair dispute resolution, because everything is under the control of a single party whom you are trusting that party is going to provide the service in a fair way. But what happens that party does not provide fair access to the service. So, the objective of this particular work that we have targeted, that our objective was to design a transparent decentralized architecture for such kind of service providing consortium while eliminating any centralized broker or marketplace. So, that way in between I do not want any kind of trusted third party which will control the entire platform like Amazon, Flipkart, eBay, Trivago, Make My Trip, Booking.com and all these different individual middlemen who actually brings up the buyers and sellers or the service providers and the service consumers together on a common platform. So, this is the title of this work which was published this year in IEEE Infocom. The title of this work was Blockchain Interoperability for Service Decentralization. This work was primarily done by my PhD student Bishak Ghosh. So, I think you have also heard about few of the tutorials from Bishak. One of our undergrad students, Tanay Bhatia, along with my collaborator at NIT Karnataka, Saurabh Kanti Addo and myself. So, we are the authors of this paper. So, I am going to just shamelessly discuss this paper with you to share our experience of designing such kind of service in the system. So, as I mentioned that our broad objective was to move from a centralized marketplace to a decentralized marketplace, something from this left side centralized architecture to have a common decentralized architecture where I will have a decentralized interface through which the consumer will be able to interact with the service provider. Now, if I try to design such kind of architecture, let us first understand that what are the requirements. The primary requirement is that while eliminating the central broker or the marketplace, we need to carefully design the architecture in such a way so that all its functionalities must be preserved in the decentralized consortium architecture as well. So my interface or my architecture should not look very different from Amazon or eBay, but at the same time it should have free from any kind of centralized control. Okay. So that was the kind of thought process behind this one. Now, first of all, I would just like to highlight that these are the kind of Amazon, eBay, all these things. I am just providing a kind of example, and this was a kind of academic research. So there are multiple different other challenges which might come from the legal aspect, from the aspect of dispute resolution, and the aspect that who is taking the charge, who is taking the control of it. So, for example, in a decentralized marketplace, it might happen that a buyer does not provide the sufficient service to the a seller does not provide the service guarantee to a buyer. Say for example, you have put up the order for a smartphone and in return you just get some empty smartphone box. If this happens, well, the system can possibly identify, if you put up a complaint, the system can possibly throw out that particular seller from the network. But how this dispute will be resolved, that who is going to pay your money, who is going to catch the buyer, catch the seller and going to refund your money, that we do not address in this particular work. So, these are the kind of open challenges which are still there. We have not thought of that dispute resolution part. What we have thought of, that how we can possibly integrate these components together to design a decentralized marketplace. But this kind of legal aspect, all these things are there, because in typical use case of Amazon, eBay or Booking.com, if such kind of problem happens, then you can give a call to Amazon, you can give a call to Booking.com, and they can resolve your problem immediately. Possibly they will refund your money by taking the risk with them, or they can provide an alternate supplier, alternate hotel to you. But in such kind of decentralized architecture, if you get cheated from one of the service providers, then how the dispute resolution is going to be done, that we have not thought of. That is possibly a open problem for you. So I would like to acknowledge that part at the beginning itself. So we are just concentrating on the design of such kind of platform. So coming back to our discussion, that what is requirement from our side is, first of all, we need a unified interface. So the consortium should have a unified interface to its customer, and the interface should be without any centralized broker or agent. Well, and consumer should be able to view catalog, query price, request for resources, get resource access information and credential, make the payment, etc. through that interface. So all these services should be available with that interface. Now the challenges that we have in this system. Well, so the first challenge is that there can be Byzantine behavior of the consortium service providers. Well, so the participant service providers might be Byzantine faulty. The service provider can maliciously try to affect the pricing, scheduling and policies of the consortium, and the service providers can be biased towards certain users and also might try to block certain users' requests by affecting the consortium agreement. Well, then the consumer can also be Byzantine faulty. They can generate multiple identities to create problem in the system. So that way the end user, the consumers can also exhibit Byzantine fault, and each user request must be agreed upon by the consortium participants to process it correctly, and these consumers can create as many identities or accounts as they want, introducing the risk of Sybil attack. So the possibility of Sybil attack can be there. And the third challenge is the verifiability and confidentiality of the information from the consortium. Well, so as I mentioned that there is no single trusted spokesperson of the consortium. So the results of the consortium, which is generated based on certain agreement of the service providers, that need to be transferred back to the end user. So the question comes that how this agreement will be manifested outside this federation, and how the end user will verify that this agreement has come from such kind of federated agreement architecture. And the final challenge is that the sensitive consortium responses must remain confidential between the consumers and the service providers. Well, now with these challenges, the threat models that we consider are as follows. First, as I mentioned, that we consider that at most 1/3 of the service providers may be Byzantine faulty, and non-faulty consumers control majority of the computing power. Then there is a possibility of Sybil attacks, that means the end user consumers can create multiple accounts or identities for accessing the consortium services. There can be impersonation attacks, that means it is a decentralized consortium. So, it does not have a single spokesperson. So, a malicious service provider might try to deceive a consumer by posing as the consortium's spokesperson. And there can be leakage of sensitive information, like sensitive information of the consortium as well as users might be exposed while passed over the decentralized network. Now, these are the kind of architectural requirements that we have. So, we have these consumers are generating the service request, and when the consumers are generating the service request, that service request is going to the service provider. So, the service provider in a decentralized way, they process the request and finally generate the response, and this response need to be again sent back to the consumers. Now, in this case, we need to have two different requirement. The first requirement is to design this interface between the consumer and the service provider, which is called as the decentralized consortium interface. So, this decentralized consortium interface should support an agreement on each user request and the ordering of the user request, and the service responses must be verifiable by the end users, and the confidentiality of the response need to be preserved. Okay. And on the other hand, at the middle we have these multiple service providers, and among multiple service provider we need to have a decentralized consortium collaboration, so that they can collectively generate or process the request and can generate the response. So, there need to be an agreement on the pricing, catalog and policies. There should be a requirement of scheduling the request. The confidentiality of the service provider information also need to be preserved. So, with this requirement, we need to design such kind of consumer to service provider interface, where the service providers will act in a decentralized way, maybe on top of a private blockchain, and the consumer can broadcast the request to the service providers, and the service providers will collectively take the decision and send back the request to the consumers. Now, while designing such kind of architecture, the question comes that how the user request will reach to the consortium, okay? Because we need to keep in mind that there is no single spokesperson for the consortium. Well, so we do not have a single web portal or address available for communication. Now, you can think of simple solution like broadcast from the consumers to the closed network of service providers, but that does not work, because certain messages might be lost and the messages might also arrive out of order. So, I need to have some kind of ordering logic on the messages. So, that is one of the primary requirement. And as I mentioned earlier, that consumers might be Byzantine faulty and they can partition the consortium. So, that way I have several challenges that we need to address while designing such kind of architecture, and the guarantees that we need to provide in this design are as follows. First, the consortium interface safety, that means the non-faulty service providers should receive the same set of consumer request and in the same order. So, I need to run certain kind of ordering service which will order the service request which are coming from different users. Well, so that ordering need to be maintained, and the second requirement is that consortium interface liveness. Okay. So, all non-faulty consumer requests are eventually received by the consortium. So, the earlier diagram that I had shown, so in that earlier diagram, So, it should ensure that whenever the consumers are sending the request to the service provider, I should have an ordering of this request from different consumers, and whenever the service providers are going to receive this request, there need to be a kind of agreement among the service providers well, to guarantee the service. Well, so these are the kind of primary requirement that we have to ensure. Now, let us think of that how we can design this interface, okay, the interface between the users and the service providers. So, I have two different users. So, as I mentioned earlier that we need to think about the network. So, the network is clear, it is a network of consumers and the service providers, and if I think of that who are the participants in this network. So, I have two type of participants in the network. One is the consumers and the second one is the service providers. Well, so it is basically a network of consumers and a network of service providers, and they are going to interact among themselves. Well, now interestingly you see that this consumer network, it is mostly a kind of open network. So, anyone can participate as a consumer. I can browse the catalog, I can see that what products are being sold, and then I can decide that which particular product I want to buy. Well, so that is a kind of we need a kind of open interface. So, we can use the public blockchain for designing this open interface. Well, so any user can join the network and avail the services by issuing the transactions, and smart contract having a fixed logical address, they can act as the single point of contract. So, through smart contract the consumers can interact with the service providers over this public blockchain network, and I can have a background mining process which will mine the blocks with the transactions, and that way the network will have consensus on each block, indicating that consensus on each user request. So, that means whenever one consumer generates one request, that request goes through this consensus procedure. Well, and each block also has a fixed ordering of transactions which actually guarantee the consensus on the ordering of the request. So, if I have multiple users which are generating the request, so the blocks which are generated on the blockchain, in that block the requests are in some particular order, and this order actually ensures me the ordering of the request, or the request need to be processed by the service providers in the order they have been added in the blocks of the public blockchain. So, that way we can use a public blockchain to generate this interface between the consumers and the service providers. So, that way the first problem that I was mentioning, that how to design that interface, this particular problem gets solved. So, this is the way we can design the interface. So, the consumers they generate the service request, this service request contract are the smart contract that mine the request from the consumers and add them in a public blockchain. So, I have this service request smart contract that execute the corresponding transactions, and these transactions gets propagated in the public blockchain network. So, the transaction is flooded among the participants and the block mining process is getting executed. That block mining process can be on proof of work, proof of stake, or other whichever mining procedure you want to use on your public blockchain network, and the moment the block gets a confirmation, so this mined block is flooded in the network and everyone can see that the transaction has been added in the blockchain. Well, so that way whenever a consumer request is generated, that consumer request is added in a public blockchain through this public blockchain mining procedure. Now comes the important question, the two important problems that we have. So, the consumer has generated the service request. this service request has been added to a public blockchain. Well, now as I mentioned earlier that the service providers they construct a private blockchain among themselves, because the service provider network is a kind of closed network. Now, because it is a kind of closed network, on that closed network the service provider can come to an agreement among themselves. And remember that why do we want the service provider as a closed network? Because in the consumer network there can be multiple different consumer. You can be a consumer, I can be a consumer. I do not need to know you. But whenever I am getting certain service from a service provider, I need to know the identity of the service provider, right. So, that way I need to have a kind of identity validation there. Well, so that way the service providers they cannot use pseudonymous identity, they have to reveal their identity to provide the service, so that the consumer can choose a particular service provider. And because of that particular reason we thought of that, well, the service provider network can be a private blockchain network from where the service provider comes to certain external validation mechanism. Okay. Again, how this external validation will be done, that we have not thought of, that is possibly a kind of I can mark this problem as a kind of possible open problem, okay, that we have not thought of in this work. We have just assumed that there would be an external validation procedure through which the service provider will come to this private blockchain network and they will form a private blockchain network among them. Okay. And then the question comes that, well, the consumer request have been added to this public blockchain through the public blockchain consensus mechanism, that is good. But how this consensus will get transferred from the public blockchain to the private blockchain? Now, for this purpose we need some way of interoperability mechanism that we talked earlier. Well, so this is one of the research question that we have, and that actually we have tried to address in this work. Okay. This is the first one. The second one is the reverse thing. Well, transferring of consensus from the consortium to the end user. Now, to transferring of consensus to the consortium, as I have mentioned that the consortium service providers cannot simply pick the request from the permissionless blockchain and start processing. So, some consortium members might not get the mine block in time and thus cannot participate in the scheduling. Then there can be malicious consortium members who may introduce and schedule invalid consumer requests that are not mined at all, and consensus protocol like proof of work they often generate temporary forks. So, that way the network might be partitioned. So, we cannot simply pick up those transactions from the public blockchain. Well, the second problem was say somehow I have picked up a transaction from the public blockchain and that request have been processed among the service provider, they come to an agreement and they return back the response to the public blockchain. So, the question comes how they are going to return this information from the private blockchain to the public blockchain, and how the consumer will believe that the response that have been appended to the public blockchain that actually came through the consensus mechanism of this private blockchain network. So, these are the kind of two open problems that I have. So, on that direction, yeah, the problem is that a single service provider cannot simply post a response on the consortium back to the user, because that service provider might be malicious. Well, so the consortium response is always based on a consensus on the same. So, the consortium consensus has no manifestation outside the private blockchain. So, that way the consortium consensus on response must be verifiable by the end users. Well, and sometimes the confidentiality of the response has to be preserved while transferring across the public blockchain network. Say for example, you have booked a ticket, so the ticket should come to you or not to anyone else. Well, so that is the requirement that we have. So, in the next lecture we are going to see about how do we solve this particular problem. So, that's all for this particular lecture, where we have tried to highlight the problem overall. So, we have seen that there is a kind of requirement from transferring the information from the public blockchain to the private blockchain, and then return back the response from the private blockchain to the public blockchain. Okay. So, in the next lecture we are going to see that how we have approached to solve this particular problem. So, thank you all, see you all in the next lecture.